All right, solvents. So for all these reactions, we basically want polar solvents. And polar solvents come from polar bonds. All right, so you're looking for things bonded to oxygen, things bonded to nitrogen, any of those kinds of things. Polar, just any type of polar bonds. We see a lot of these in lab. You see diethyl ether. You see chloroform. You might see ethanol. Oh, I don't know. You see DMF. There's lots of different types. So these are all polar, and the reason I know they're polar is because they have polar bonds. They have atoms that have differences in electronegativity, right? Carbon and chlorine. Now, when we start doing some of these SN1, SN2, E1, E2 reactions, we also add in not just this idea about polar bonds, but this idea about protic versus aprotic. And really, we should think of these terms about, essentially, it's about hydrogen bonding at the end of the day. And can you hydrogen bond with yourself? So things that are polar protic can do hydrogen bonding with themselves, meaning they have, right, these are the polar protic ones. They have OH, NH, SH, pH bonds, right? Those are polar protic solvents. Polar aprotic solvents essentially are polar, but they don't have any of these. So another way to think about it, they can't do hydrogen bonding with themselves, right? And that's one of the things we learned when we talked about intermolecular forces. So you should be able to recognize those things again. It's just now using it in kind of a different context. So SN1, E1 prefer these polar protic solvents. You can imagine the OH, NH, SH, and pH don't really mix well with E1 or E2 and SN2 because those have really reactive bases and nucleophiles. So things with a negative charge might react with a polar OH, NH, SH, or pH. So polar aprotic, classically, most times, work for SN2 and E2 because they don't want their nucleophiles or bases reacting with protic things. So they like aprotic. Whereas E1 and SN1, a lot of times, these solvents are either the base or they're the nucleophile, actually. It's like a solvolysis idea. So that's the big key. Everything's polar. Protic, aprotic. Protic, you can do hydrogen bonding with itself. OHs, NHs, SHs, PHs. So, and then aprotic is polar, but no of those bonds. Aprotic, SN2 and E2. Protic, E1, SN1. So like diethyl ether, polar aprotic. Ethanol, polar protic, OH. Or chloroform, CHCl3, polar aprotic. No, none of these. DMF, dimethylformamide, polar aprotic, right? There's no OHs, NHs, or SHs. So that's just kind of an example of how to look at it.